Okay, Bismillah ar-Rahman ar-Rahim. So today we're going to talk about the last part in chapter 5, which is the main function of the network layer or the router, which is routing. So so we'll take a quick look at how the routing is actually performed. So basically what the router does is that once the router starts its operation, you have to start the interfaces. So each router has multiple interfaces or ports that are connected to different networks. So the best way to understand this is to imagine that you are at a roundabout or a big intersection, and then there are different directions which are represented here using like interfaces or ports, okay, that you can go through. So whether you go here or you go here or you go here, the piece of information that you need to use to figure this out is what? The destination address. The destination address. Okay? So what the router does when it first starts, it tries to discover the networks that are directly connected to it. And that's something that it can recognize on its own. It doesn't need any... So it knows that this street is called X, this street is called Y, because these streets are directly connected to the intersection. So that's an information that's given to each router. Each router knows exactly the networks that are directly connected to it. So it knows that this network, this interface is connected to a network with an address 192.168.2.1/24. And this is the address of this interface, which is 192.168.1.0/24. So this means that the network address for this is 192.168.1.0, okay, and the network on this other side is 192.168.1.0. So this is the networks that are directly connected to it. So these networks, it can be placed, or the router will place it in the routing table by default and mark it as directly connected networks. Okay, so that's given. Okay. What it doesn't know is that how can it reach a network, a remote network like this, or a remote network like this. Okay. So assuming that we will have to give it this information one way or another, there are two methods. The first method is what we call static routes. By static routes, we mean that these are manual routes that the network administrator will have to put it manually in the routing table. So the network administrator will configure this router, will perform like certain commands to see the routing table, and then it will update these routes in the routing table manually, which means that it will say, okay, so if you want to reach to a destination address of 10.1.1.0, which is this one, any host on this network, okay, so any host will have the last zero will have a number in there. It will be 2, 3, 4, whatever. Okay, so any host on this network, if you need to reach it, you can go via or through the interface that has the address 192.168.2.2, okay, and you have to spend only one hop to get there. This one is the number of hops you need to get there. So you only need to go one hop and then you will find it. Okay, so that's what this means. If you want to reach to the destination address 10.1.2.0, which indicates any host on that particular network, then you can go via the same interface, interface, or the same remote interface on the router, okay? And again, the cost is one, which is the same. So that's what this means.
So what's 120? That's before.
120 indicates the what they call the administrative ID, which indicates the routing protocol that generated this route. Okay, so that's not a static routing protocol. This has been generated by a dynamic routing protocol, which is the RIP or R. R stands for RIP. So R stands for RIP, and RIP has an administrative ID of 120. Okay, so 120 indicates RIP. And 120 also indicates, I don't want to get to more details, but it also indicates some kind of a priority. So if you have 120, 120 has less priority compared to like 110 or maybe 70 or something like this. So this means that if any protocol puts a route in the table with an administrative ID which is less than 120, then it will take priority over RIP. That's not. This is details. You don't have to really understand this 100%. But what we need to know is that directly connected networks are known by default. Once I wake up, I know I can discover these directly connected routes. And remote networks, I can get the knowledge from these networks through the router that is directly connected to them. So this router will have to inform me about the networks that are directly connected to it.
Yeah.
That's if we're talking about dynamic routing protocol. Static routing protocol, and I don't know this information initially, but the administrator will let me know that. The administrator will go to the router, and then it will enter manually. If you want to go to this network, you need to go via this interface. If you want to go through this network, you have to go through this interface, and so on. Okay, so this is the difference between dynamic routing protocol and static routes. Static routes are entered manually by the system administrator. Dynamic routes, they get updated automatically through some routing protocols like RIP. There are some other protocols like OSPF, EIGRP, and so on. There are tons of other routing protocols. Through these routing protocols, what they do is actually they facilitate the exchange of directly connected networks from one router to another. So all they do is that they enable each router to gather all the information about the directly connected networks, and then they send it to all the routers in the neighborhood. So this way, the information about the remote networks will propagate its way to the different routers. And that happens automatically. And there are tons of issues related to this that luckily we will not go through as part of this course, but you will have to go through if you take 466. Okay? So dynamic routing protocols are very, sophisticated, and there are tons of characteristics and features that each routing protocol provides over the other routing protocols, but this is part of another course. Okay. Okay. So now we need to discuss. What do you think are the advantages and disadvantages of each type of routing, static routing or dynamic routing? First, what is the advantage of static routing? Do you think it has any kind of advantage?
Maybe it's faster. Because you're defining, not waiting the other routing to give you the data.
Faster?
It's easier in a way.
It's easier, yes. Yeah. It's easier. You don't have to worry about running sophisticated dynamic routing protocol in your network and so on. You don't need any dynamic routing protocol. You can just put things manually. Yeah. But what is the disadvantage of this?
So it's that you have to go to every router and configure it.
You might do some mistakes and get faster results.
True. So anything which is done by human is subject to errors, right? Yeah. But errors here are very expensive. Errors here may lead to routing loops, and you can have packets get lost through finding its way, and it's not that good. So Not only that, you have to worry about manually updating these routes every time you have a network change. So if one router goes down, one router gets introduced recently to the network, you have to go to all the routers and re-update based on the new topology or the new change in the network, which is not feasible. So static routing can be feasible only if you have a very small network, like maybe you have 2 routers at home and you can configure it yourself, and you don't think that this is that there is any possibility of changing these routes or something like this. So this can be useful in that regard. You don't have to run a sophisticated routing protocol. So what about the advantages and disadvantages of routing, of dynamic routing protocol? Well, the advantages are clear. The routes are updated automatically. You don't have to worry about changing the routes every time there is a topology change or a dynamic change in the network. Okay. And of course, you have to worry about the disadvantage here is that once you get to dynamic routing protocol, you have to worry about so many issues that might happen. For example, you have to exchange information throughout the network about the directly connected routes. So how do you do that? How do you propagate this information in the network? Do you have to flood the entire network and send it to everyone? What is the boundary of this flooding? What if one router inconsistently puts some incorrect routes in the table? This will get, not only it will affect this router, but it will affect all other routers because all the information propagate in the network. Security issues. Like if you get into one router and again update its routing table by any chance, in the static routing category, it only affects this router because the routes are not exchanged between the routers, right? But here, if you change anything in the routing table of one router, this will propagate through the entire network, and it may affect the entire network. It can be really, really bad. So there are some disadvantages to routing protocols that have to be addressed. But you do have to address this if we're talking about a large network, because for large networks, static routing is not an option. It's just not an option. You cannot have like a human being going through all the routers every now and then to maintain and to create and modify the routes. It's just not an option, right? So you have to have a routing protocol. And that's why we have tons of routing protocols. We have REP, we have OSPF, we have EIGRP, IGRP, we have border gateway, and so as I said, what is the limit? What is the boundary of this routing protocol? Does each routing protocol have to know the everything about the internet? Does this make sense? So the routing protocol knows every single router on the internet? It's not possible, right? So what about scalability? So we're talking about scalable internet architecture. So how can we do that? So this can only be done through like some hierarchical way of routing. So router will have a boundary. If it goes beyond this boundary, then it has to go through other routing means or other routing protocols. They call it border gateway protocols. So once you get to dynamic routing, although the concept sounds fancy, but you have to address and worry about so many issues before you say, I was able to design a routing protocol. It's not that easy. So all this complexity can be avoided if you can use static routes, but this also is, this is only feasible if you have a very small network. So as we said, once the router will start, it discovers automatically the networks that are directly connected to it. So that's one network, that's the other network. So it places these networks in the routing tables by default, and it indicates that these are directly connected, so I don't need to go to a remote router to reach these networks. I can reach them directly. And when a router is configured with an IP address mask on the interface, router knows exactly that this interface has this network address and put it in the routing table accordingly. So so that's the dynamic routing protocol. So the dynamic routing protocol facilitates the fact that these for this router, these are directly connected networks. So the dynamic routing protocol facilitates the fact that this router will get the information about those two networks, will put it in a form of a message, and then it will send it to the other router. So this router will then process this message and get from it the fact that these remote networks can be reached through this router. So it knows that if it wants to send to these remote networks, it goes through this remote interface. And of course, one of the issues that you have to deal with, what if you have multiple routes for the same routing network? For example, you have a path that looks like this. So you will get the information from this router about these directly connected networks, and then this router will inform this router about its directly connected networks, and then this router will inform this router about these remote networks. So in that case, you have received two messages that tell you you have two ways of reaching these networks. So which one do you select? Are you going to select the shortest in terms of number of hops, or are you going to select the fastest? So it becomes like, which is similar to like Google Maps, and so there are tons of metrics that you can use to evaluate the quality of a certain route, whether fastest, least loaded, the one with the lowest probability of traffic jams, the one that's shortest, so which means that in terms of number of hops, this one is the shortest. The one that does not have, like for example, wireless, so because wireless has a higher probability of error. There are tons of criteria that you can use to design your metric. So a route has three pieces of information. Of course, it has more, but these are the ones that we care about. The destination network address, which is this one, okay, and the next hop, which is this one, and the metric. The metric is one, this number. So if it's 2 hops, then it's 2. If it's 3 hops, 3, and so on. So RIP, and this is one of the disadvantages of RIP, uses number of hop as a metric, which is the most trivial, the easiest, but not necessarily the most efficient. Okay. So static routes talk about manually entered by the administrator, and dynamic routing protocols, they include, these are some examples. You don't have to know the details of these routing protocols by any means. But the first 3 protocols, these are like normal dynamic routing protocols. They use different metrics to identify or to evaluate the quality of the route. They use different mechanisms to exchange information. These IS, and border gateway protocols, these are hierarchical routing protocols that are used to route between the internet service providers. So within the network of one internet service provider, you can use one of these routing protocols. And then this border gateway protocol is used to route between service providers. So you have huge network for AT&T, you have huge network for Ooredoo, you have some other networks, And then if I want to go to the US, for example, should I go through this service provider or this service provider or this service provider? So this is a higher level of routing. Once you get there, then you use one of these routing protocols to navigate your way through the network. It's like I want to get to a specific house in the US. So first I have to go to the airport, so I have to find my way to the airport. Then I have to take the airplane. So the airplane is like border gateway protocol. So it takes you to the other country, and then you get to the other country, and then from there you have to route your way through to reach the house. So these are different levels of routing that makes your routing in the internet more scalable and efficient. Okay, so what about, okay, so now we want to see that, okay, so the router here, this is the router. The router now received a packet. Okay, what does it do exactly? So what are the steps that the router has to go through in order to route the packet? Well, the packet comes on the physical layer, and then it gets pushed up in the stack to the data link layer. In the data link layer, the data link layer will say, okay, does the physical address match my own physical address on this particular interface? Each interface on the router has a physical address and IP address, okay? So the data link layer inside the router will say, okay, does the physical address match my own physical address? If the answer is yes, then it pushes it up in the stack. It goes to the routing layer, and now the router has to perform packet forwarding. So the first thing it does is that the router removes layer 2 encapsulation, and then it extracts the destination IP address from the packet. The destination IP address in the packet is 10.1.2.0. Okay, so this is the destination network address. Okay, so the first thing that the router will do is that it will look up this address in the routing table. So the router will check the routing table for this particular address. Assuming that we can find this destination address directly in the routing table, which means that it's either directly connected or it's a remote network that I have an entry in the routing table how to get there. So in that case, I found it. So what I need to do is that I need to forward it on a specific interface or a specific port. So in that case, what I need to do is that I will have to re-encapsulate again and put the physical address of the remote interface of the router. صح? We said that physical address will have to change hop by hop, remember? Okay, so re-encapsulate the packet and put the physical address and put the destination address as is in the IP header, and then I forward it on that interface. So that's one scenario, that I received a packet with a particular address, and I consulted the routing table, and I was able to find that address. So that's a happy path. So nothing exceptional happened here. Another possibility is that I received a packet with a particular destination address, which is in that case 172.16.2.0, and I did the same, and then the network address was not in the routing table. Okay, then I have to ask myself, do I have a default route? Remember the default route that leads you to the gateway, the default gateway, which takes you to the internet. So if you don't have a specific route for this particular address, then the next level is to look for this default route. So the default route in that case exists, and the next hop is 192.168.1.2, which leads you to the default gateway that gets you to the internet. So in that case, even though I was not able to find a route entry in the table directly, but I can use the default route to forward the packet. Okay? Any questions so far? So the third scenario is that I was not able to find this address, and this router is not configured with a default path or a default route. Okay? So in that case, I can just discard the packet. I don't have any, so I cannot just say, I don't know any route for the packet, so I will just forward it randomly, or I will just throw it again on the network. You shouldn't do that. The router does not do that, and it should not, because this is very dangerous. This indicates, or this might mean that the packet will lose its way and will start circulating in the network, and you don't want to get to this. So the third possibility is just to discard it. So another fourth possibility here, which is what we have discussed before, which is what?
Route the upper until the number, the maximum number of routers, and then it's
TTL, so the time to live. So the first thing I do before checking the IP address is I have to check the TTL field. Okay? If I check the TTL field and I found that the TTL field is 1, then I subtract 1 and then it becomes 0. So regardless of whether I have a route for this packet or not in the routing table, I have to just remove it. Okay? So in that case, I don't have to even read or consult the routing table or anything. Okay, so that's another exceptional scenario that could happen. Okay, so if I do all of this and again I cannot see any route for this particular packet, then the normal behavior is just to discard it. So static routing. In that case, the routing, as we said, the routing entries will have to be put in the routing table manually. So router A. So the network administrator will have to access router A, and then it will have to add these addresses manually in the routing table. So the network administrator has to have the global picture of the entire network in that case, which hopefully is a small network that can be manageable in terms of static routing. So router A will have to be configured with all with the next hub for all the remote networks, and then I have to do the same for router B and so on, and the same for each network. For dynamic routing, as we said, the dynamic routing has to go through some transient stage. So at the beginning, when you first start your network, you start all the routers. So each router will have to gather the information about the directly connected networks, and then it will have to form a message and send it to the next router. And then the next router will have to update its own table, and then get the information from the table, put it in the message, and then send it to the next router, and so on. Okay, so we can imagine that during this transient stage, the tables in all the routers are not necessarily consistent, right? So the tables are not updated, are not up to date, right? So before steady state, you may have inconsistent tables, in which case, if you start sending packets right away, you may end up with lots of routing loops and so on. So it's advisable when you start your dynamic routing protocol on each router that you have to wait for 1 or 2 minutes to allow all the tables to become consistent, to allow all these messages to go back and forth, and create some kind of a steady state situation that all the tables are up to date. And that happens if all the routers receive the routing messages and they find no new information in these routing messages. Okay? So another complexity in the dynamic routing protocol is when you actually recognize or identify that you have reached to this steady state. It's also not that simple in some cases to recognize that, okay, so all the tables in all the routers are up to date. That might take maybe 1 or 2 minutes at the beginning. Okay? So the routers share routing by using this, what they call route update messages. So part of any dynamic routing protocol is what we call route update message. So a route update message will summarize the information in the table of each router, and then it will send it to all the other routers. And it will send it to all the other routers in the neighborhood. So I don't send it to this router, I just send it to the neighboring routers. Then the neighboring routers will have to update their own tables based on this message. And then the next step is that they will have to summarize whatever in their table and then send it to all the other routers, and so on and so forth, until we reach to the steady state. As we said, dynamic routing or routing information protocol, RIP, uses the shortest path to evaluate the quality of the route. On the other side, RIP, one of the disadvantages of RIP is that it keeps sending route updates regardless, even if you are in the steady state. This is the simplest way. So logically, if I reach the steady state, you don't have to update anything because the route updates do not have any new information, right? But RIP does not actually recognize the steady state. It does not have any kind of recognition that you have reached the steady state. So it just keeps sending route updates periodically. So every 3 seconds, it sends route updates, regardless. Okay, so that's the simplest type of protocol. EIGRP, on the other side, it does have some mechanism to recognize that this is the steady state, and then it stops route updates, which kind of, is more efficient, and then only triggers route updates if there is a topology change. If there is a topology change, one router goes down or something like this, then it triggers route updates based on that. So it's more efficient in that sense. It does not send route updates periodically and blindly, regardless of whether you are in a steady state or not. EIGRP also considers a more complicated metric, so it does not use the number of hops. It does use the bandwidth and the delay of the link to evaluate the metric of the route. So it does use a complicated way of measuring. So if the bandwidth is high, this means that the cost of sending a packet on this link is low because it has a very large bandwidth. It's like it's the same concept that Google Maps uses, for example, to route. If you are going through a highway, okay, then it's preferable compared to going in a small road inside the city, right? So the cost of going through the highway is much less compared to the cost of driving in a small narrow street. So that's what EIGRP does exactly. So it uses a composite metric of bandwidth and delay and so on to measure the metric on the route. OSPF uses a similar approach. However, there are some differences when it comes to how they calculate the metric and how they exchange the route updates. So the route updates in OSPF, they get flooded into the network. So they flood the network with route updates as opposed to just sending to the neighbors. So there are some differences between the two routing protocols. Again, I mean, the details are not of concern to you, but this is just a small overview. Why we need multiple routing protocols? The issue is that once we talk about dynamic routing protocols, it's complicated. You have to address so many issues. And depending on what issues you have to address, your routing protocol can be complicated or can be simple enough. Okay? So, so I think we'll stop here so that we can start next time with with chapter 6. Chapter 6, I think we'll go through it a little bit faster because you have covered that in the lab.